Let's take a look at this problem, which is a person crouching, and we have a figure here that's geometry of the heel. So you have the leg coming down to the foot. Here's the heel. That's the Achilles tendon here with a tension T on it. And there's a force F from the tibia down onto the heel here, down onto the foot. And then we have the total weight of the person who's crouching at 700 newtons here. So the question is, what are T and F? What do we have? We have the total weight. We have the distance between this pivot point where the bones meet and the Achilles tendon, and with the distance between this pivot point and where the center of mass on the weight is. And we know the angle between the Achilles tendon and the horizontal. So how are we going to go about approaching this? Well, this is first and foremost, right? This is a statics problem. So the sum of all the forces must be zero, whatever all the forces are, and I'll just stick a little force of I on there. Sum of all the forces must be zero. The sum of all the torques must be zero. All right, so we've got to make sure all the forces add up to nothing. We've got to make sure all the torques add up to nothing because nothing is moving here. Torques would cause rotation, and non-zero forces would cause translation in one direction or another. So let's look at what we have. If we look at the horizontal components, right? Horizontal components of all of this, um, you know, so in the horizontal direction, the total has to be zero. So it's not just, the forces, but even in just the horizontal direction, the total has to be zero, right? So what are the horizontal components? Well, there's the tension T sub x, right? Minus F sub x equals zero. And we know T sub x is just whatever the tension on the Achilles tendon is times the cosine of 38 degrees, right? So whatever the tension ends up being, we know T sub x is T cosine of 38 degrees. And we look in the vertical direction, T sub y minus F sub y also has to be zero. And in this case, we know T sub y is whatever the tension is times the sine of 38 degrees. Okay, now we have essentially two unknowns, well, three unknowns, fx, fy, and t. But that doesn't tell us everything, right? We got to go to the torques. So let's pick a pivot point. And I'm going to start by picking the pivot point to be right here. Why? Well, if you recall, a torque is a distance crossed with a force. And if we pick this point right here as our pivot point, the distance between the force F of the tibia on the heel or on the foot is zero. And so the torque due to that goes away. And so let's start looking at that, right? The torque due to this, the Achilles tendon, is going to be Ty, which is vertical, right? Because it's just a component that's perpendicular to the plane of rotation we're the line of rotation we're interested in, right? So Ty times that distance 0.6 centimeters, right? And I'm going to call that negative because that generates a left-hand rotation. So Ty, T sine of 38 degrees, okay, times 0.6 centimeters. And again, I said I was going to call that negative because that causes a clockwise rotation, and counterclockwise rotations are positive. And now we have the other one, which is going to be plus the 700 newtons times the 5 centimeters, and that has to add to 0. Well, because we were a little clever in choosing our pivot point to be at one of our unknowns, namely the force F, we have this equation that tells us everything we need to know to find T, and we don't have to do any more work. All right, so T is just going to be 700 newtons, 5 divided by 0.6. The centimeters cancel out. Get this up on the screen, and we're dividing by sine of 38 degrees. Okay, so that's what we're after. 700 newtons, 5 over 0.6, 1 over the sine of 38 degrees. Let's take a look at this. And this is how you're going to want to do your homework. So we have the weight, which is 700 newtons. We have a distance 1, which is 0.6 centimeters. We have a distance 2, which is 5 centimeters. We have an angle, which is 38 degrees. And I'm going to go ahead and convert that to radians because Excel uses radians, right? And so now our tension T is going to be 700 times 5 divided by 6 divided by sine of the angle. And so that's the tension on the Achilles heel. Now, no wonder people pop their Achilles heel all the time, right? Because here you are, 700 Newton person, and you've got over 10 times that much force that's being exerted by the Achilles tendon. Why? Because that lever arm is so short compared to that one, right? And now we want to find the force F. So there are a couple of ways we can go at that. We've got the tension T. And since we have the tension T, we can do very simply from this first equation. I made a mistake here. And because this also has plus 700 newtons in it, my bad. This first equation, Fx, is just going to be T cosine 38 degrees, right? And Fy is going to be 700 newtons plus T sine of 38 degrees, all right? So T cosine 38 degrees gives us Fx. 700 newtons plus T sine 38 degrees gives us Fy. And then F total is just going to be square root we have to add the components correctly, right? Basically finding the length of the hypotenuse of the triangle formed by those two legs of the force. And so here we are. We have T. We want Fx. So Fx is going to be T times the cosine of the angle. Again, you have to make sure you use radians. Fy is going to be 700, our weight, 700 plus T times the sine of that angle. All right, and then our total F is just going to be square root of Fx squared plus Y squared. So our total F is 9,921 newtons. And that's it for this nice little problem, right? I'll put the values in. So T is 94.74, 94.75. 94.75 newtons, and F is 99.21. And that's it for this little example problem. Hope it helps.